Welcome to Random Sampling. Hello. Okay, I'm there.
Oh, you're embarrassing, but that's okay. We like you anyway. All right, so moving on to section 3.3, random sampling and data collection. This is an important section. We're actually going to do it kind of a little differently, so bear with us. Couple learning objectives there. You want to?
So with this lesson, with this 3.3 lesson, half of this lesson is going to be video lecture style like you have been doing, and then the other half of this is going to be required live lecture. So we're going to stop about halfway through the 25 slides of this lesson and jump on down to the assignment, but you will be required to attend the second half of this lecture live, okay? All right, so let's jump right into some, yeah, okay, whatever. I didn't say on site, I just said live.
Yeah, we're going to do some things. Okay, so essential knowledge, there's a lot of definitions in this section, and they're really important stuff that we know. The first one, and I think we've kind of talked around this a little bit. You mentioned this in an earlier video, the idea of a census, and not the government census, although that's kind of, they're trying to. A census is when you're able to get everything in a population. We talked about the trucks. I can't get all of the trucks, but we compared that to Lakeside trying to get a hold of every family to find out what each family wanted. So that's, if we're able to get a hold of everything in whatever population we're focusing on, then we have completed a census. It is very difficult to do a census, though. In practical applications, in most situations, it's not possible.
So another thing that we talk about is we've used the word survey a lot. We're going to survey our families at Lakeside and ask them questions, right? Or we want to know something about trucks on the road, and so we're going to take a sample. We talked about this sample of the population. Well, when we choose those items from our population, that group is called the sample, but what we're doing is we're sampling the population, or the
Population. Mm-hmm.
Yeah. So there's a couple of ways that we can do this. We can do this without replacement, meaning we can pick and we can pick and we can pick, and when we've chosen, we are not going to enter those things back in the population to be chosen more than one time. We can also choose to sample with replacement, or sometimes we can't avoid that situation. And so this is when, like, I'm picking, but I could potentially pick the same person all over again. So that is called sampling with replacement. So there's a couple of different kinds of sampling that we're going to have to identify and work around for this course.
For example, like a game warden monitoring fish in a river. He could take the fish, but if he keeps the fish out of the river, it's going to die. So he has to throw the fish back.
Do you know how to actually do that? They actually send an electric current into the water, and the fish come up to the surface.
Yeah.
Isn't that absurd?
Yeah, but that's how they do it. Well, anyway, I was trying to not be graphic, but fine, you be graphic. Okay. All right. So anyway,
it just shocks them.
Yeah.
And then they're alive again. Most of them, I'm sure, anyway.
All right. Thanks for that shocking revelation. So we're not going to use the word survey anymore. It's a sample. Even if we're surveying people or trying to find out who you're going to vote for president, we're sampling the people who are the voters. Okay, so we're going to try to use the word sampling all the time, whether it's, and that makes it clearer for people versus items, I think. Okay, so the first way we can do this is just what we call a simple random sample, and we're going to go through these rather than like define them. We're actually going to do them. Okay, so you want me to move on with the next slide, or
a simple random sample is when you are randomly selecting, and there's a few ways that we randomly select. The way you'll do it the most often in this case is just to use the random number generator on your calculator, but you could do other things. There's what's known as the table of random numbers. We won't do that in this class, but that does exist. Sometimes you might see that. You could draw decks of cards to represent the randomness. So there are different ways that you can get those random numbers. Generally, though, we will just be using our calculators and the random number generator. Okay.
So then there's two other ways when randomly picking people using a random number generator, throwing numbers in a hat or a random number table isn't always feasible or economically valuable. We could do it with what's called stratified, where we use divisions when we worry about certain underrepresentations or overrepresentations of certain populations or certain groups within our population versus, ethnic groups or, different types of animals or whatever. And we classify them and then choose from each so that we do get a representation of all those different subgroups.
Now, remember when we're sampling, what we're trying to do is we're trying to get an honest representation of the population. And so the reason we want it to be random is because we don't want to apply our own bias into what's happening, right? Or even if it's not our own bias, even if it's just easier for us to attain the sample a certain way, that's going to afflict something going on. Like, let's say I want to know something about the population in a city, and I just go to Walmart and ask people, well, do you think I'm going to get an honest representation of the entire city?
On to me for Walmart example earlier, so.
Okay, whatever. So
all right.
Stratified is another way that we can try to remove bias. Clustering is the same way. Let's say it's really difficult to get all over a city to sample. Well, I could cluster the city to make sure that I get all the neighborhoods, and then send people to each neighborhood to get a random person from those neighborhoods. So that's clustering, right? When I'm literally the area they are. Or if I'm at the grocery store and the bottom shelf, which is always the kid height. So guess what they put on that shelf? Kid cereal. So I might stratify, I might pull samples from cereal populations by clustering them by their shelves.
Right. And that's back to the game warden. They could try different rivers and get a bunch of fish from one river and then go to, because it's very difficult. They can't get every river in the state of Arkansas. So they're going to go shock some fish in the Washita River. Then they're going to go shock some fish in the, up north or something. They're going to go to a different river.
Right.
So, all right. Another one we're going to talk about is a systematic random sample. Again, a lot of times I can't just go everywhere. If I were a game warden, I can't drive all over the state of Arkansas. So I'm going to pick certain things and do it systematically. So I may take a fish or go to the Washita River and take some fish here and then go 2 miles down that river and do it again, and then 2 miles down the river again. So I pick a starting point and then go in predictable increments so that I spread out.
Yeah. Another way to think about the systematic is maybe you want to sample the entire school, right? So that the first person arrives at 7 o'clock. So let's say you get there at 7 o'clock, you pick a random number. I'm going to choose now the whatever 5th person that comes in, and then the 10th person from every person after that, right? So now, and then you just stand there until the majority of the population or all of the population has come in. Obviously, some people are absent, so you're going to be having some problems there. But especially if there's a football game and there's no football players, you've lost a whole part of your population. So systematic is when you start with a random and then you choose at a fixed interval, every 10th or every 20th after that. And then there are advantages and disadvantages to all of these methods. So you generally try to pick the one that you think is going to eliminate the bias as much as possible. And then also that's actually feasible for your study.
Yeah, you also don't have unlimited resources and time, and that's a problem. Okay. So random sampling is absolutely critical, and if you don't talk about random and when you're doing a problem, you're gonna be wrong. Okay, pretty much when we're doing a write-up of a problem, you're gonna have to say, I randomly sampled. It's pretty much how you can almost begin every problem almost from here on out.
Or this was a random, generated from a prompt, right?
The problem may tell you that the data was gathered random, and if it doesn't, then you can't do it, okay? But we're going to have to acknowledge random. Like, put a star next to the word. I wish I could like have it, on my forehead in Sharpie or something. You must randomly sample because we want to avoid what's called bias. We want to try to be fair and accurately represent the population we're surveying, okay? So again, we talked about simple random sample is the most generic way where you just number whatever from 1 to however many and pick them using some form of random number generator. And I know you think this is crazy, but there actually are books of random numbers. There's tables. So like I could flip open a book of random numbers and go like this, and there's my number. Go on Amazon, you'll find plenty of them, and the reviews are hilarious. Okay?
And the idea of the simple random sample is to get every single person or every single item in the population an equal chance of being selected, right? That way you aren't imposing any of your own opinions or your own thoughts or your own ease onto the population when you choose your sample.
Okay, so we're going to look at a few examples with, and I know that there's lots of political opinions and a lot of stuff, and by the time you get around to watching this video, it's going to be a different, remember, it's happy July Christmas, 5 months until Christmas right now, but it might only be 3 months until Christmas or less. It is Happy Christmas in July. That's like a thing, isn't it?
I mean, maybe not for me, but maybe for some people.
It's not for me, but yeah. There are people that have their Christmas decorations up now, but whatever. All right, so there's lots of stuff you can find, all things on the internet, but we're gonna just talk about how the data is collected. Okay, so we're gonna talk about New York City and some of the people who tested positive for the COVID-19.
Yeah, so remember, if you remember just months ago, New York City was one of the first cities in the United States to be hit really heavy. So they got to be like the United States guinea pigs, if you will. So what happened is when COVID-19 spread to New York, the city only provided tests to people who showed symptoms. Well, later, we've realized that there are a lot of people walking around who are positive carriers who are asymptomatic. And so what's the problem with only testing people who are showing symptoms? Well, you've lost all the carriers who aren't showing symptoms. So what that led to was an underestimate of the number of people that ended up being infected, and a false sense of security when you go out into the world, because you think, oh, there's not that many people who are carrying and could get me sick. So that was a bias within their sampling.
Wouldn't that also show a higher positive test rate? I would think if they only tested people who showed symptoms, their success rate of testing would have been, the test showing positive would have been higher than actually it might have been otherwise. So otherwise, it wasn't accurate on a couple levels. Okay, so what New York City should have done, even though they didn't at the time, we didn't know, we were making this up as we went, they should have numbered everybody in New York City, give everybody one of those little numbers, and randomly tested everybody, or based on every time there was a test, they should randomly pick from 1 to 5 million or whatever many people there were and test that person to get it into account.
Yeah, so if we had done that, if we could have randomly sampled New York City, and that would have given us an unbiased estimate. Now you have to remember too that your unbiased estimate of something like a pandemic is changing every single day.
That would be ridiculous. The number of them, I don't even know the population off the top of my head of New York, but it's millions.
Yeah.
And that person, and I mean, that just can't happen. You understand the problem with the population, okay?
Right.
So let's look at a couple possibilities, okay? So how would you implement, I guess I kind of already jumped the gun on this, but if we had a population of, let's make it to 1,000, how would you go about doing this? Well,
So
do you want me to click?
before you click through, let me say this. It feels weird. One of the things that we have to teach you is how to write the statistics, because a lot of what statisticians do is they write for the researchers and they write for the public so that they can understand what's going on. And you have to be clear and concise and explain in a wishy-washy way. And it's hard. It's one of the hardest parts about being a statistician, in my opinion, is writing in a way that's informative, easy to understand, but not too concrete.
And accurate, yeah.
Accurate, yeah. So it says, how would you describe or how would you implement a simple random sample? Well, there are 3 things you have to cover, okay? So if you click through, Mr. Bobby,
okay.
The 3 things you need to cover when you are describing how you're going to perform a simple random sample for a study is, first, you've got to assign each individual in the population, which, remember, we're saying individual because we're talking about New York City and COVID, but it could be fish in a lake or whatever. So assign each individual in a population a number 1 through n, whatever that population size is. If we were talking about fish in a river, this would actually not be possible. We couldn't possibly assign every fish a number because we don't know how many there are. Okay, so there are reasons why there's more than one method that we talk about. The second part of the simple random sample is using a number generator to obtain however many numbers you want, making sure to skip repeats. Okay, so if I want 1,000 people, I'm going to have to generate 1,000 numbers, but I'm going to skip any numbers that are repeating. So I'm probably going to end up generating more than 1,000. And then number 3 says, sample the individuals whose number were generated. And this is important. Like if you, for some reason, generated a number from somebody who was unreachable or passed away or whatever, you've got to generate another random number. You can't just like pick their brother.
And if you keep it kind of, when you're writing yours for the AP exam for us, you don't have to say, I put it in the calculator and generate, just say, use the random number generator. Keep it generic, okay? So there's an assignment of the numbers, there's a generation of the numbers, and then there's a sample of those numbers, skipping repeats, okay? So, okay. Ready to go?
Yep. Now let's look at what it should look up, the right should look up. So take a second, pause the video, write it up the way you think it should sound.
Remember your 3 things.
Okay, so now that you have an idea of what you think it should sound like, let's see if we match. Assign every individual in New York City an integer 1 through 8.9 million. Okay, I looked up the population. It's not exact, okay, it's not exactly 8.9 million, but whatever. You could put 1 through n. Use a random number generator to obtain 1,000 integers between 1 through n, which is that 8.9 million or however many there are, skipping repeats. Make sure in your write-up that you told us that you're skipping repeats. Remember, with replacement, without replacement, 2 very different things. Administer the COVID test. Did you say that? Did you talk about what you're doing?
On text.
You got to talk about it to the 1,000 individuals whose numbers were selected. So, hope you did well. All right, Mr. Bobby.
All right. Was a bug on my ear or something. I don't know, some itchiness. All right, now, did that seem logical or simple to assign 1 to 8.9 million to all the residents in New York and then to survey those 1,000 people? That ain't gonna happen, right? That's gonna be a lot. That's pretty hard. So there's other methods for situations where it's just too difficult to do a simple thing.
I mean, not only is it sometimes too difficult or impossible, but sometimes we might want to know more, right? Or we might be concerned that our one sample might have too many of one type of person, right? What if we accidentally get a sample that's like a bunch of 16-year-olds? Well, we found that those people are not being as affected by COVID-19, and that might not be a true.
Yeah, age is a great determinant for COVID-19, or at least that's what they think now. So
Who knows what happened 3 months from now?
by October or whatever. So how can we implement a stratified where we're worried about overrepresentations of different groups? Well, and we want to do 900 residents this time, I guess.
Why not?
Okay. So you kind of fed us this. We now, at least now in July, know that age is a determining factor, or at least has an influence. And we actually have known that. I think they've known that for a while. And there's even, so we could, what we do is stratify our groups, or classifies is another way of thinking about it. We're going to put them into categories or whatever. So under 18, 19 to, or under 19, 19 to 30 and 40 plus. And we're going to assign numbers within each of those strata and choose 300 from each of the groups. You skipping repeats, and then administer to those 900, but 300 in each strata. Why 300 in each strata? Well, we want to make sure that each group is equally represented. Okay.
So now you know why I switched it from 1,000 to 900 to make it easier.
So much nicer. Okay, are we good here?
Yep.
Kind of giving you some examples. Okay, the next one is cluster sampling. If we were concerned about age being a determining factor, then that was how we would handle it with the stratified sample. Why would we want to use a cluster sample, Ms. Young?
So I might be concerned that some neighborhoods are more affected, some neighborhoods are less affected, or I might like only have a certain number of vans that I could send out into the community to test people. And so it might make sense for me as like a person who has limited resources to cluster my samples into regions and then to send a like testing van. Those don't exist. So if they exist like in October or whenever you're watching this, then I just made something up. But
there are only so many doctors that they can assign, and the doctors have to be, so
right.
Yeah. Okay.
So cluster sampling. Take a second, think about it. How would you cluster? And remember this, because this is crazy about statistics. Every single one of you can cluster in a different way and potentially all be right. So don't think that just because you didn't write what I wrote that you're wrong. Like, there are elements that we're going to be looking for, and the elements are those three pieces. Okay.
So we would she divided it in 10 regions and then numbered the people in each of those regions and obtained 1,000 from each of those regions. So geographic, she did it by geography. If you're familiar with New York City, there are 5 boroughs. Is that what they call them? You could have broken them into those. That way you're making sure that you're representing each of the areas. Okay. Systematic sampling is the next one. Okay. So let's think about that. We still want to, now you want to do 89.
I gotta switch things up so that people stop and think,
Okay, so she's
super creative with this one. If you were going to systematically sample, what would you do?
Well, the way systematic sampling, I would number all the people, or if I were going to say the way systematic's supposed to work is you number all the people, and then you pick. Actually, you pick. So there are 8,900. Oh, I see why you did it now. There's 89 million people, or 8.9 million. I'm going to take 1/1000th of the first 1,000 people and generate a random number from 1 to 1,000. Okay. And then I'm going to, so suppose I pick, 66. Okay. And then I'm going to add all the people in New York City are going to be numbered, but I don't have time to do all the random number generator, or I just want to be sure to spread them out. So I'm going to pick 66, and then I'm going to add 1,000 to that and do 1,066, and then add another 1,000. So you're going to keep doing it in a process. So you're still numbering them all, but you're not doing a true random sample. You're picking a starting point and then going by that fixed increment. And she did 89 because it's 8.9 million. I get it now. So I could have clicked that a while ago. Yeah, and I even did it. I could read your mind. Okay. But that's what she was saying is like if you're standing at Walmart, you want to try to mix it up. You pick a starting point. So you say, okay, I'm going to survey every 20 people, every 20th person. So let me pick a random starting point from 1 to 20. So you use a random number generator, pick a number from 1 to 20, and then you're going to pick every 20th person after that one. Okay. That's not perfect, but it's a way of having an element of randomness when you can't always
I mean,
tell.
especially like when you think about choosing a random pop, like just at your school, you know, and I talked about this, like standing at the front door and maybe you want to pull your people. Think about how difficult it would be to not to assign everybody a number because the school already did that, or even to random sample them. But now you've got to go find them. You got to go classroom to classroom, and they're changing classrooms every 50 minutes. And so you're like bopping around all over the school. It's gonna take you forever to get a big populate or a big sample. So, but if you're standing at the front door and you're just like 1, 2, 3, 4, 5, 6, 7, 8, hey, 1, 2, 3, 4, 5, 5, hey, that's a lot easier than trying to bop around the school and talk to people.
But again, sometimes having easy may cause other problems later on, and that's what we're going to.
Like if the football team is gone that day, well,
Right.
you're not talking to any of those people.
Yeah, and we have SX football players don't have opinions anyway. So
Oh, shut your face.
I think this is the end of what we're going to do
Yeah,
in
so
recording.
there is a lot more to this. If you clicked into these slides, because you're the kind of person who likes to print off the slides, there's like a whole second half of this, okay? We're going to talk about neighborhoods, and we're going to talk about, well, you'll see, in a live lecture. So the assignment that's going to go with this, you can see below here, you're also going to start AP Classroom Unit 3 Multiple Choice A. And that should already be assigned to you. And then look at your calendar and see when the live lecture for this, the second half of this is going to be. Or it's not even a lecture because we're not lecturing, but it's like an activity, live activity.
We actually want to do all these methods with you and have all gather data and see what happens. Okay, so that's going to happen live. And if you can't do that live, you can join it. You can watch the recording after and then do this assignment.
Yeah. Okay. Thanks for joining us, guys. We hope we made some sense with you, and we will see you live. Bye.